Okay, here's the question then. There it is there. I've summarized it here. So I'll put the first part in here for part A. Write down the vector AB. Here's A and here's B. So AB would be 7 minus 1 is 8I. Then A to B, minus J minus 3J is minus 4J. And then 5 minus 7 is 12. Okay, so there's the vector A to B then. C lies on AB such that AC to CB equals 3 to 1. Find the position vector of C. So let's have a look at B here. Let's call it a little C vector. So it's on the line AB, so we can write down A straight away, can't we? Minus I plus 3J minus 7K. So there's A. And then it go to A, and then AC to CB is in the proportion of 3 to 1. So that's 3/4 of the way along AB, isn't it? So it's plus 3/4 of the vector AB, because it's 3/4 of the way along. 8I minus 4J plus 12K. So 3/4 was because it was 3 parts of the whole thing is 4, so 3/4 of the way along. So what have we got here then? We've got minus I plus 3J minus 7K plus 4 into 8 goes twice, so that's 6I. 4 over 4 is 1, so it's minus 3J when we expand this bracket. And 3/4 here, 4 into 12 goes 3, 3 3s are 9. So what have we got? We've got minus I plus 6 is 5I. 3J minus 3J cancels. Minus 7 plus 9Ks is 2K. 5I plus 2K. So that's the position vector of C. Position vector of OC. Okay, so that's that part done. Line L is this. Find the line parallel to L through A. So part C, 1. So here we'll call it R. The line is equal to parallel to L through A. So again it's the vector A, which is listed here already. And it's parallel to L, and this has directional vector here. So let's put mu minus 4I plus J plus 3K. So there's our line then, parallel to L through the point A. Verify that B is at the foot of the perpendicular from A to L. Verify that B is at the foot of the perpendicular from A to L. So the line, let's draw the line L. There it is there, okay? There's A, then. Okay? So verify that B is at the foot of the perpendicular from A. So if we drop a perpendicular here in 3D space, we want to verify that that point there at the foot of the perpendicular from A to L is B is here. So there's two things. Is B on L, and is this vector perpendicular to this vector? Basically, it's the two things we need to verify. Okay, so let's have a look here then. So firstly, B is on L. So for that to be the case, the position vector of B is 7 minus 1, 5. So let's just put that in. 7 minus 1 and 5. So there's B. So here 7 needs to equal the line L is here. So minus I minus 4 lambda. Minus I minus 4 minus 1 minus 4 lambda. So that would tell us then Move the 4 lambda over. And move the 7 over as well. Minus 1 minus 7 is minus 8. So lambda is equal to minus 2. Lambda equals minus 2 then gives... What do we get for lambda equals minus 2? R equals then? Well, we know it would be 7i. What's the j position on the L? Lambda is minus 2. Minus 2j plus 1 is minus 1. And the k vector, lambda is minus 2, so that's minus 6. 11 minus 6 is 5. So that's plus 5k. So B is on L, because this is the same position as the position vector B. Also, the vector AB then, AB, dot with the direction of the line, which is this directional vector, and it's the same as that one, so we can just write that down. Minus 4i plus j plus 3k. Now, does this equal 0? Well, AB, let's just get AB again, sorry, click up. 8 minus 4, 12. 8 minus 4 and 12. Dot product with minus 4i plus j plus 3k. Okay, what do we get? 8 times minus 4 is minus 32. Minus 4 times 1 is minus 4. And 12 threes are plus 36. So, yes, that's right. So, AB is perpendicular to line L. And that's the two things we needed to verify.